Here we have a graph y versus x. I haven't bothered to label the axes, but maybe I should. And on this graph, what we want to do is, it looks like these points tend to lie along a straight line. And what we want to do is we want to find the best straight line that fits these points. Now, often what people will do, if they have a bunch of data points, is they'll simply make a line from the first point to the last point. And I'm going to demonstrate in terms of this picture why that's not the best way to get a good straight line that fits the data. So if we do that, well, I kind of missed the last point, but you get the idea. Okay, so maybe I'll just cheat and move that last point a little bit. Okay, so now I've got a line that does a very good job of going through these 4 points, but not such a good job of going through these 3. Let's put a scale on this graph. Let's just say that this is 1 unit here, and this is 1 unit here. So that our first point is 1, 1, and our second point, well, let's see, we go 1, 2, 3, 4, 5, bring this point down, 6 would be about here. It looks like this is about 6.2, and over here, if that's 1, then here's 2, here's 3, 4 would be up here. I'm going to say this is about 3.7. So let's just say this point is 6.2, 3.7. This point is 1, 1. Now the first thing we're going to do is we're going to find the equation of this line. And to find the equation of this line, we're going to use a method that really generalizes a little better to the things that we do, as opposed to using a point slope formula or a 2-point formula or some sort of a formula for finding the equation. So we're going to do some just a little bit of mathematical analysis here. And I don't think you're going to find this excuse me, too awfully difficult. We know that a straight line has the form y equals mx plus b. And to find the equation, we just have to find the values of m and b. So find the equation of the line. Find the values of m and b. Now, how can we do that? Well, you know, or you should know perfectly well, that we could easily find the slope of this line. Okay, from 1 to 6.2 is a distance of 5.2. From 1 to 3.7 is a distance of 2.7. So that we have a rise of 2.7 and a run of 5.2. So the slope is 2.7 divided by 5.2, which is pretty close to 0.5, just a little greater than 0.5. Actually, it's a little less than 0.5. I don't know what I was thinking. And so we could easily determine the value of m. And having found the value of m, it's not too difficult to find the value of b by any number of methods. However, that's not what we're going to do. We're actually going to find this equation by using simultaneous linear equations. So I'm going to write a couple of things on the board so you don't have to sit there and watch me write. So we're going to find m and b by setting up and solving simultaneous linear equations. Now, this is something that those of you who haven't yet had Algebra 2 might not have seen by this point. I'm not sure exactly where you see that in the curriculum. Fortunately, it's pretty easy, at least when you have 2 equations. And we're actually going to do some things where you have 3 equations. That's a little more challenging, but it's really not too difficult to pick up, so don't be worried about that. Okay, well, what I mean by setting up and solving two simultaneous linear equations is this. You know that y equals 1 when x equals 1. So 1, 1 implies that y equals 1 when x equals 1. Now, if the point 1, 1 is on the equation of the, if the equation of the line gives you the point 1, 1, then y has to be 1 when x is 1. The equation's y equals mx plus b. We don't know what m is, we don't know what b is, but we know that when y equals 1 and x equals 1, the equation has to be solved. So, 1 equals m times 1 plus b. Now, the point 6.2, 3.7 implies that y equals 3.7 when x equals 6.2. So, what is our conclusion? If the equation has the form y equals mx plus b, then what does that tell us if y is 3.7 and x is 6.2? You should think about that, have an opinion, so that when I write it down, you know whether you agreed with me or not, and you get a little feedback, okay? So, well, that means if y is 3.7 and x is 6.2, then we have 3.7 equals m times 6.2 plus b. And now we have two equations. Now, if you have two independent equations, and don't worry about that word independent right now, these are independent equations, but if you have two independent equations in two unknowns, then you can solve to find those two unknowns. Well, our two unknowns are m and b. So we have two unknowns, m and b, two equations. 1 equals m times 1 plus b, 3.7 equals m times 6.2 plus b. Now, I'm going to rewrite those equations up here so that we can work them out. Okay, so, and I'm going to reverse the sides of the equation. We know that that's not going to hurt anything. And instead of 1 times m, I'm just going to write m. Instead of m times 6.2, I'm going to write 6.2m. So I'm going to have m plus b equals 1. And for the second equation, 6.2m plus b equals 3.7. Okay? Now, this equals this, and this equals this. If we, there are two ways we can solve this equation. Now, we could solve this equation, the first equation, for either m or b. For example, m equals 1 minus b. Then we would know that m is equal to 1 minus b, and we could put 1 minus b in, substitute it for m, and then this equation would have only one unknown. We would substitute 1 minus b for m, so the only unknown would be b. So this equation would then give us an equation in the variable b. Excuse me a second. Okay. Now, this is the first equation. This is the second. So now I put the second equation first, and negative 1 times the first equation under that, just to get the negative underneath the positive. We can write them in any order. It's not going to make any difference. Remember that this is a statement of equality, and this is a statement of equality. So when I multiply this statement of equality by negative 1 on both sides, it's still a statement of equality. And this equation is unchanged. It's a statement of equality. Now, if I add this side, and then I add this side and this side, since this equals this and this equals this, the sum of these sides has to equal the sum of these sides. So I can say that 5.2 times m, which is what we get if we subtract m from 6.2. If we subtract 1 of something from 6.2 of something, we end up with 5.2 of that thing. And then b minus b is 0. So I could write that as plus 0. And that's going to equal 2.7. 3.7 minus 1 is 2.7. So this is still a statement of equality, which of course can be written 5.2m equals 2.7, so that m equals 2.7 over 5.2, which equals what? Well, if this was 2.6 over 5.2, the result would be exactly 0.5. Now, 1 part in 27 is about approximately 4%. So if I increase 0.5 by 4%, I'm going to get something like 0.52. So I'm going to say this is approximately 0.52. Again, you should be able to think along those lines, and if you simply practice a little bit, you can. Naturally, a calculator is going to give you a little more precise result, and it's going to differ from a 0.52 by just a little bit. Now that's consistent with what I said earlier. We could have just taken these 2 points and calculated m, and that would have been the end of it, just calculating the slope, at least as far as m is concerned. Now what we're going to do then is we're going to take this value of m and we're going to plug it into, let's just say, the first equation. And let's draw an arrow all the way from here down to here. And that's going to give us what? Well, if m is 0.52, then we get 0.52 plus b equals 1. And that's very easily solved. We get b equals 0.48. So now the equation is y equals mx plus b. That was our original assumption. We've evaluated the parameters m and b, and we find that m is 0.52, so we get y equals 0.52x plus b, which is 0.48. And that's the equation of the line through this point and this point. We have this equation. In the next video, we're going to see whether this equation does a reasonable job of fitting the points, and if there's a line that might do a better job of fitting these points. I mention that because that might well be a method you're familiar with. I'm not going to use that method here because we're going to use what we call the method of elimination, which again you might be familiar with, and if you've had Algebra 2, you certainly are familiar with it. Okay, in the method of elimination, we've noticed that if we were to subtract one of these equations from the other, then we would have a b in one equation and a minus b in the other equation. B would go away, and we would be left with an equation in just m. And that's the method we're going to use. So what we're going to do is we're going to do the first equation, which is 6.2m plus b equals 3.7, and -1 times the second equation. Okay, in other words, we multiply through the second equation by -1, which gives us the equation -m minus b equals -1. Okay, now I said we're going to subtract the second equation from the first, and actually what I'm doing is multiplying the second equation by -1, and then I'm going to add it to the first equation. That's a little less prone to error than subtracting one equation from the other, especially if the equation you're subtracting already has some minuses. You can get messed up with the minus signs. So what I'm just trying to do here is I'm multiplying the second equation, and I've called this the first, I've called this the second. This is actually the first, and this is the second, so let me correct that.